Good morning to all. Welcome to our channel Learn and Crack. Today's topic of discussion is the universe. I have divided this topic into three parts. In first part, we will see the definition and formation of universe, our galaxy, our solar system and about the star sun. The part 2 is about the planet system and brief explanation of solar system explorations. Part 3 is about minor planet system. Definition of universe. The universe is the name that we use to describe the collection of all the things that exist in space. It is made of many millions of celestial bodies and enormous clouds of gas separated by a gigantic empty space. The celestial bodies include galaxies, stars, planets, comets, asteroids, meteoroids, etc. Cosmology is the study of universe. Formation of universe. The Big Bang theory is a cosmological model about how the universe began. The idea was proposed by an astronomer, George Lemaitre, in 1927. It is the idea that the universe began as just a single point, then expanded and stretched to grow as large as it is right now. That is, at the beginning of universe, there exists an initial state of extremely high density and high temperature particle mixed with light and energy. As everything expanded and it took up more space, it cooled down. Over the lots of time, the grouping of tiny particles leads to the formation of stars, asteroids, comets, planets, black holes, etc. The theory is compatible with the Hubble's law. The observation that other galaxies were moving away from us and the farthest galaxies were moving faster than the ones close to us. That means the universe was still expanding. Extrapolating this cosmic expansion backwards in time, the theory describes a state of singularity in which space and time lose meaning. The Big Bang occurs at around 13.8 billion years ago, which is thus considered as the age of the universe. Galaxy. A galaxy is a large collection of stars, glowing nebula, gas, and dust bound together by gravity. Nebula means bright or dark clouds, often composed of gases, hovering in the space between the stars. Milky Way is our galaxy and it formed at around 4.5 billion years ago. Andromeda and Magellanic Clouds galaxy are galaxies near to us. Milky Way. Based on the shape, there are four main categories of galaxies: elliptical, spiral, barred spiral, and irregular. Milky Way is a barred spiral galaxy, which means it has a central bar as shown in figure 3. Milky Way galaxy has four major spiral arms and some minor arms. The major arms consist of the highest densities of both young and old stars, while the minor arms are primarily filled with gas and pockets of star forming activity. The four major spiral arms of Milky Way galaxy are Perseus, Norma, Scutum Centaurus, and Carina Sagittarius. Our solar system is located in one of the minor arm of galaxy named as Orion Syncus, which is about 30,000 light year from the center of the galaxy. The Orion arm is lies between two major spiral arms named as Perseus and Carina Sagittarius. This is a pictorial representation of our solar system. Sun is at the center and other celestial bodies like planets, asteroids, dwarf planets, etc. are revolving around the sun in fixed orbits. Planets. Planets are celestial bodies that have fixed path in which it moves around the star. They can't produce energy but just reflect energy from stars. In the case of solar system, there are 8 planets which revolves around the sun. They are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. These planets are divided into two main types. First one, smaller rocky terrestrials. Second one, large low density giants. The terrestrial planets or inner solar system includes Mercury, Venus, Earth and Mars. They are made of rocks and metals. Silicate is the main composite of crust of these planets. The mantle and core is made of nickel and iron. The terrestrial planets have no planetary rings and have no or few natural satellites. The outer planets or giant planets or Jovian planets includes Jupiter, Saturn, Uranus and Neptune. Jovian means Jupiter-like planets. Jupiter and Saturn are gas giants made of hydrogen and helium. The Uranus and Neptune are ice giants made of substance with a relatively high melting point called volatiles like ice, methane and ammonia. Outer planets are encircled by planetary rings and possess numerous number of natural satellites. All the planets rotate about its own axis in anticlockwise direction, that is west to east. Also, except Venus and Uranus, all the planets revolves around the sun in anticlockwise direction, that is west to east. There exist two belts, that means asteroid belt and Kuiper belt. The asteroid belt which lies between Mars and Jupiter and Kuiper belt which is found beyond the orbit of Neptune. Sun. The sun is the star at the center of the solar system. It is the most important source of energy for life on Earth. It is mainly made of gases like hydrogen and helium. It formed approximately about 4.6 billion years ago. It accounts for about 99.86% of the total mass of the solar system. The structure of the sun contains core, radiative zone, convective zone, photosphere, chromosphere, transition region, and corona, as shown in the figure 5. Core. The core of the sun extends from the center to about 20 to 25% of the solar radius. The nuclear fusion occurs in this core region and leads to the releasing of enormous amounts of energy that makes the sun shine. The temperature of this zone is about 15.7 million Kelvin. Radiative zone. This region lies between about 25% to 70% of the solar radius. Energy from the core slowly rises in the radiative zone. In this region, energy transfer occurs by means of radiation. It takes the energy about 1 million years to travel out of the radiative zone. Tacker line is the boundary region between radiative and convective zone. Convective zone, which lies between about 70% of the sun's radius and a point close to the visible surface. This region carries energy to just beneath the sun's surface. Photosphere or solar surface. It is the deepest part and is visible by our naked eye. The temperature of this region is about 10,000 degree Fahrenheit. This is the part that gives off light. It takes 8 minutes for this light to reach Earth. Chromosphere or red layer is a thin layer of gas above the photosphere. The convective zone carries energy to just beneath the sun's surface. Corona is a thick layer of gas above the chromosphere. It is the outermost layer of sun. Along with the chromosphere, it is only visible during a total solar eclipse when the sun's surface is completely hidden behind the moon. The solar filaments are dark filamentary objects on the solar disk. When they move to the solar rim by the rotation of the sun, they show bright loop structures in front of the dark space background, which are also called as prominence. For the complete understanding of solar system explorations, primarily we need to know about the types of spacecrafts. Robotic spacecraft are classified into 8 broad classes. First one flyby, second one orbiter, third one lander, fourth one penetrator, fifth one rover, sixth one observatory, and seventh one communication, and finally navigation spacecraft. Flyby spacecraft. Flyby spacecraft conducted the initial reconnaissance phase of solar system exploration. They follow a continuous solar orbit or escape trajectory, never to be captured into a planetary orbit. They must have the capability of using their instruments to observe targets they pass. Prime example of the flyby spacecraft category is the pair of Voyager spacecraft, which conducted encounter in the Jupiter, Saturn, Uranus, and Neptune systems. Other examples include Stardust Cometary Sample Return, Mariner 2 and 5 to Venus, Mariner 4, 6 and 7 to Mars, Mariner 10 to Mercury, Pioneer 10 and Pioneer 11 to Jupiter and Saturn, New Horizon to Pluto and Kuiper Belt mission. Orbiter spacecraft, a spacecraft designed to travel to a distant planet and enter into its orbit for the deep study of that particular planet. Prime example of the orbiter spacecraft category is Galileo, which entered orbit of Jupiter. Other examples include Messenger Mercury Orbiter, Mariner 9 Mars Orbiter, Cassini Saturn Orbiter, Mars Global Survivor, Mars Odyssey, Ulysses Solar Polar Orbiter, Magellan Venus Orbiter, etc. Atmospheric spacecraft. Atmospheric spacecraft are designed for a relatively short mission to collect data about the atmosphere of a planet or satellite. The prime example of the atmospheric spacecraft category is Huygens, which was carried to Saturn's moon Titan by the Cassini spacecraft. Lander spacecraft. These are designed to reach the surface of a planet and survive long enough to telemeter data back to Earth. Prime example of this category is Mars Pathfinder. Other examples include Viking Mars Lander, Venera 13 Venus Lander, Survivor Moon Lander. Penetrator spacecraft. Surface penetrators have been designed for entering the surface of a body, such as a comet, for measuring and telemetering the properties of the penetrated surface. The examples for this type of spacecraft are Deep Impact Mission to a comet named Temple, IcePack mission to Jupiter's satellite Europa, Lunar A mission to Earth's moon. Rover spacecraft. Electrically powered rover spacecraft are designed, assembled, tested, launched, and operated by NASA's Jet Propulsion Laboratory as part of the effort to explore Mars. The first Mars rover, named Sojourn, was carried by the Mars Pathfinder lander, which successfully touched Mars surface on 1997. Other two Mars exploration rovers, named Spirit and Opportunity, landed in 2004. Observatory spacecraft. An observatory spacecraft does not travel to a destination to explore it. Instead, it occupies on Earth orbit or a solar orbit from where it can observe distant targets free of the obscuring and blurring effects of Earth's atmosphere. The prime examples of this category spacecraft are the Switzer Space Infrared Telescope Facility and Hubble Space Telescope. Communication and navigation spacecrafts. These are launched to Earth's orbit for improved communication and navigation facilities. For example, GSAT, that is geostationary satellites. These are India's indigenously developed communication satellites used for digital, audio, data, and video broadcasting. USA's GPS satellites are examples for navigation spacecrafts. Missions to Sun. This is a list of most important missions launched to study our star Sun. First one, Genesis. It is a orbiter spacecraft mission launched by NASA. The operating period of this mission is between 2001 to 2004. It was the first spacecraft to capture a sample of the solar wind. The solar wind means the constant stream of particles that emanate from the sun. This mission made a hard landing in 2004. Second one, Solar and Heliospheric Observatory. It is also a orbiter spacecraft mission. Its period of operation is between 1995 to present. It is a work of collaboration between the European Space Agency ESA and NASA to study the sun and observing all the way from its core out to the solar wind. Its major observations include studying the sun over two 11-year solar cycles and information about the sun structure. Third one, Transition Region and Coronal Explorer, launched by NASA. Its goal was to better understand how magnetic field and plasma act in the sun's environment. Fourth one, Ulysses. It is a collaborative work of NASA and ESA and which is designed to look at the heliosphere. Fifth one, York or Solar A. It is a Japanese-led spacecraft from the Institute of Space and Astronautical Science. Sixth one, Solar Max mission. It is launched by NASA and which is designed to study the sun at the height of its 11-year solar cycle when solar flares and coronal mass ejections tend to be most frequent. Seventh one, Hinoth or Solar B. Its operating period is between 2006 to present. It is launched by JAXA, means Japanese Aerospace Exploration Agency. It focuses on the solar corona. Eighth one, Solar Terrestrial Relations Observatory. Its operating period is between 2006 to present. Launched by NASA. Its achievements include showing the three-dimensional structures of CMEs, means coronal mass ejections, and showing how matter and energy flow to Earth from Sun. Ninth one, Solar Dynamics Observatory. It is launched by NASA and its goal is better understanding of solar activities. 10th one, Interface Region Imaging Spectrograph. It is also by NASA. It focuses on interface region, that is lower levels of the sun's atmosphere. 11th one, Parker Solar Probe. It is a orbiter spacecraft mission launched by NASA in 2018 and expected to reach the solar orbit in 2025. Its goal is close-range solar coronal study. 12th one, Solar Orbiter. It is also a orbiter spacecraft mission launched by ESA in 2020. Its goal is solar and heliospheric study. Aditya L1. It is India's proposed spacecraft mission to study the sun. It is designed and will be built in collaboration between ISRO and various Indian research institutes. It is planned to be launched by the end of 2020 and it is the India's first solar mission. In this video, we discussed about the universe and the sun in detail. The part 2 and part 3 of this topic will upload soon in my YouTube channel. If you like the video, please share it and subscribe my channel for more videos. Thank you.